the 6 decades since the establishment of NASA, space exploration has led to several groundbreaking discoveries about our universe. The space agency has helped uncover many unknown facts about our world and possible events. From planets to galaxies at the edge of the unobservable universe. The most recent is the possibility of the Sun destroying our world. Join us in this video as we look at NASA's latest revelation on how the Sun could destroy the Earth in 2025. The Sun is a living, breathing star at the center of the solar system and is the most important energy source for life on Earth. For years, scientists at NASA have sought to visit this star, believed to be over 4.6 billion years old. We can't blame them for wanting to learn about the star-shaped ball of hot plasma that radiates light, infrared and ultraviolet radiation. Heated by the nuclear fusion reactions in its core, with a radius of 695,000 kilometers and a mass 330,000 times that of the Earth, there is so much to discover about the Sun. Since 1958, NASA wanted to study the particles and fields around the Sun, but was held back by the project's high cost. They finally got the opportunity to tick this goal off their bucket list when the Solar Probe mission was included in the 2009 US fiscal budget, allowing the project to begin in early 2010. Initially named Solar Probe Plus, a $1.5 billion spacecraft was designed and built by the Johns Hopkins University Applied Physics Laboratory. The laboratory completed the spacecraft in 2017 and renamed it Parker Solar Probe in honor of astrophysicist Eugene Newman Parker, who coined the term solar wind and is an emeritus professor at the University of Chicago. Parker Solar Probe is the first NASA spacecraft named after a living person. What's more interesting is that the launch rocket of the spacecraft is in memory of APL engineer Andrew Dantzler, who had worked on the project. On the 12th of August 2018, Parker Solar Probe was launched into space to study the Sun's outer corona. The spacecraft was designed to approach within 6.9 million kilometers from the Sun's center and is the first to fly into the low solar corona. Having a launch mass of 685 kilograms and a dry mass of 555 kilograms, Parker is the closest ever artificial object to the Sun, and it is expected to undergo its mission for 7 years. Parker's mission is to assess the structure and dynamics of the Sun's corona plasma and magnetic field, the energy flow that heats the solar corona and propels the solar wind. With Parker, astronomers seek to study the mechanisms that accelerate energetic particles. If you are wondering how Parker Solar Probe can travel close to the Sun without getting damaged by its radiation, you have the researchers at the Applied Physics Laboratory to thank for that. They equip the spacecraft with a solar shield that protects its systems from the extreme heat that comes from being close to the Sun. The hexagonal-shaped solar shield protects the spacecraft from the Sun's incident solar radiation, which is about 475 times the intensity in Earth's orbit. The shield is mounted on the Sun-facing side of the spacecraft, and it is 2.3 meters in diameter and 11.4 centimeters thick. With its 2 panels made from reinforced carbon-carbon composite, the shield can withstand temperatures outside the spacecraft of about 13,270 degrees C. The 73-kilogram shield helps the spacecraft's instruments to maintain a temperature of 29 degrees C, and its white reflective alumina surface layer minimizes absorption. Scientists at the Applied Physics Laboratory designed the spacecraft's systems and instruments to be located in the central section of the shield's shadow, blocking out direct radiation from the Sun. The probe takes about 8 minutes to communicate via radio with the Earth in each direction. You can see why the spacecraft acts autonomously and rapidly to protect itself from the Sun's radiation. The 4 light sensors of the probe serve as a lookout in this process because they help detect the first traces of direct sunlight from the shield's limits. In response, they engage movements from reaction wheels to reposition the spacecraft within the shadow once more. Parker Solar Probe is the fastest object ever built and was described by the project scientist Nikki Fox as the most autonomous spacecraft ever flown. A dual system of solar panels primarily powers the probe's mission. The spacecraft's trajectory will cover 7 Venus flybys over nearly 7 years until it slowly shrinks its elliptical orbit around the Sun for 24 orbits. Due to the high launch energy required for Parker Solar Probe's trajectory, It was launched on a Delta Vavor heavy-class launch vehicle and an upper stage based on the Star 48BV solid rocket motor. Using its instruments, Parker first observed magnetic switchbacks, sudden reversals in the solar wind's magnetic field, on the 6th of November 2018. Measurements from the probe's findings helped scientists confirm the hypothesis that Alfvén waves have a major role in understanding the mechanisms behind the coronal heating problem. The probe succeeded in observing 1,000 rogue magnetic waves in the solar atmosphere responsible for increasing solar winds by as much as 300,000 miles per hour. Also, thanks to the solar probe, there is further evidence that some winds have a rough, irregular texture. In its travel, the probe helped NASA uncover evidence of a cosmic dust-free zone of 3.5 million miles radius from the Sun. On the 25th of September 2022, scientists at NASA had a reason to celebrate because the solar probe made its first discovery of a comet. Before now, the spacecraft had only identified previously discovered comets from images uploaded into its system. By 2025, it is expected to travel at the closest approach to the Sun at 430,000 miles per hour, mph, which is about 0.064% the speed of light. While this is great information, it is nothing compared to evidence that suggests the Sun is capable of producing superflares that can unleash 10 times or more energy than the Carrington event. What is the Carrington event, and why should you be bothered about it? You will find out in a moment. Although it's been over 150 years since it happened, scientists continue to remember the Carrington event. You can't blame them for choosing to remember the most intense geomagnetic storm recorded in human history. Sometime in 1859, the Earth experienced a geomagnetic storm that would have made some people think the world was ending. The Carrington event lasted from the 1st to the 2nd of September 1859, creating strong auroral displays worldwide. So it wasn't a Europe or a North American thing. The aurora was reportedly seen globally. The geomagnetic storm caused sparks and even fires in multiple telegraph stations, shutting down communication for days. Scientists believe the storm was likely caused by a coronal mass ejection, CME, from the Sun colliding with the Earth's magnetosphere. Beyond damaging telegraph stations, the Carrington event is closely linked to a very bright solar flare that occurred on the 1st of September 1859. Richard Christopher Carrington and Richard Hodgson observed and documented the flare independently. Thanks to the effort of these two British astronomers, we have our first records of a solar flare. However, the most intriguing part of the story is that the Carrington event occurred a few months before the solar maximum. The Sun has an 11-year cycle, and its period of greatest solar activity occurs during the solar maximum. This period is characterized by the appearance of many sunspots, with its solar irradiance output growing by about 0.07%. One of the events associated with solar maximum is the occurrence of large solar storms. It is difficult to predict when the solar maximum will happen or its strength. Nevertheless, scientists rely on the theory that it takes an average solar cycle to go from one solar maximum to the next, with the duration observed varying from 9 to 14 years. In the history of solar maximum events, the Carrington event remains the most intense solar storm ever. The coronal magnetic ejection CME was believed to have caused the geomagnetic storm to travel down the Earth, taking 17.6 hours to make the 150 million kilometer journey. Although CMEs take several days to reach the Earth, this one was different and traveled quickly because of an earlier CME. This prior CME is likely the cause of the large aurora event that occurred on the 29th of August 1859, clearing the way for the ambient solar wind plasma for the Carrington event. While astronomers were unaware that the solar storm would occur at the time, they were lucky two of their colleagues spotted the solar flare. Working independently, Richard Christopher Carrington and Richard Hodgson were two amateur astronomers who recorded the first observations of the flare just before noon on the 1st of September. Carrington had seen a blast of white light on the Sun's surface and had been investigating a group of dark specks on the Sun known as sunspots. According to Carrington, he had detected a single outbreak of light that lasted for 5 minutes while residing in Redhill, a small town outside of London. The independent reports of Carrington and Hodgson were published side by side in the monthly notices of the Royal Astronomical Society. Their drawings of the event were exhibited at the November 1859 meeting of the Royal Astronomical Society. However, they were not the only ones who had observed the solar flare. Scottish physicist Balfour Stewart observed a geomagnetic solar effect in the Kew Observatory magnetometer that day. The next day, September 2nd, he observed a geomagnetic storm using the magnetometer. Magnetic sensors at the observatory detected magnetic disturbances on Earth from the 28th of August till the 7th of September 1859. After Carrington became privy to Stewart's observations, he suspected a solar-terrestrial connection. Further, reports of the 1859 event emerged worldwide, forcing American mathematician Elias Loomis to compile and publish them. The publication helped support the observations of Carrington and Stewart. So, it's not surprising that the event was named after Carrington. One thing that made Carrington event hard to forget was the auroras people saw worldwide. Aurora, also known as polar light or northern lights, is a natural light display that is usually seen in high-latitude regions around the Arctic and Antarctica. Auroras come in a dynamic pattern of lights whose appearance ranges from curtains, rays and spirals to flickers covering the sky. They are produced by disturbances in the magnetosphere caused by the solar wind. The Earth is not the only planetary body where aurora occurs, as most planets and some natural satellites also host aurora. In most cases, auroras occur in a band called the auroral zone, which is typically between 3 degree to 6 degree wide in latitude and between 10 degree and 20 degree longitudes. However, auroras may be seen below the auroral zone if a geometric storm enlarges the auroral oval. This was what happened in September 1859. According to a report, the aurora across the Rocky Mountains of the United States was so bright that its glow woke up gold miners. The miners began preparing breakfast, thinking it was morning already. Those living in the northeastern part of the United States could read a newspaper using aurora's light. The aurora was visible from the poles even down to low-latitude areas like Queensland, south-central Mexico, Cuba, Hawaii, China, and southern Japan. People living near the equator, like Colombia, could see aurora's light. The Carrington event greatly affected communication during that period. The geomagnetically induced current from the storm led to the failure of telegraph systems across North America and Europe. In some cases, operators suffered electric shocks while the telegraph pylons threw sparks. Although some operators could still send and receive messages with disconnected power supplies, most couldn't until the system was repaired. Since the Carrington event, there have been other solar storms, but they were less severe. Nevertheless, there is still reason to be fearful because the Earth would be greatly affected if a solar storm similar to the Carrington event occurred today. The occurrence of a Carrington-like solar storm will lead to years-long power outages. That's right, you heard correctly. Unlike 1859, we depend more on electricity. A solar storm of that magnitude will throw the Earth into perpetual darkness. From the light in our homes to our phones and some vehicles, we rely on electricity for many human activities. We can't even begin to imagine the mayhem due to such a solar storm. Hundreds of lives will be lost as hospital equipment that uses electricity will be shut down. Also, businesses will be grounded and economies will suffer a decline in a matter of days because the storm will knock off the world's energy grid. Now, think of what would happen if the power outage remained for decades. So, you can imagine how scary the thought of another Carrington-like solar storm happening anytime soon. The solar storm will be nothing compared to the geomagnetic storm that occurred in 1989, blacking out the entire Canadian province of Quebec within 90 seconds. According to NASA, the storm kept 6 million customers in the dark for 9 hours. It didn't stop in Canada alone, as the effect of the storm was felt in New Jersey, damaging transformers and a nuclear power plant. The storm nearly took down the US power grids from the eastern seaboard to the Pacific Northwest. A 2013 study revealed that a Carrington-type storm would lead to over $2.6 trillion in revenue loss in the North American power industry alone. A similar solar storm will destroy radio communications and GPS navigations by disrupting the atmosphere and modifying the radio signal paths. Our satellites are not safe either, as the geomagnetic storm can heat the Earth's upper atmospheric layers, causing them to swell and drag down the satellites into low Earth orbit. Our activities in space by telescopes and rockets will be halted because the high-energy radiation from the sun is harmful to the human body. The Carrington event's energy is equivalent to about 700 billion nuclear bombs. The fearful thing is that the superflares from the Sun are far greater than that of the Carrington. You would agree that our world is not prepared for a solar storm of this magnitude, nor do we deserve to be on blackout for multiple years. Hopefully, our governments come together to prepare for this possible disaster. If we prepare well, the possible damage caused by the solar storm could be minimized so the world's energy grid remains intact. Also, we can never tell what other discoveries about the Sun Parker solar probe will uncover. Who knows? NASA might just get data that helps us predict the exact day the geomagnetic storm will occur. Thanks for watching this video till the end. If you want to enjoy more mind-blowing discoveries like this, click the next video on the screen.